Hello and welcome, everyone. We're continuing on chapter 4, and today we're going to look at graphing parabolas and graphing them without a calculator. So I think this is kind of a cool lesson because we kind of use what we know about the parent graph table. We know what we learned in the previous section about moving them to now graph them, and we'll be able to graph them without Desmos or without a graphing calculator. So first thing we're going to do is look again at the parent graph. Remember, the parent graph is y equals x squared, and our table for that always is -2, -1, 0, 1, 2. Remember, the x value of 0 for our parent graph is the vertex, and then we add 2 points to the left and 2 points to the right. And -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So that's how we get our parent graph table as a reminder. And when we go ahead and plot those points, we do end up with our parabola with a vertex at 0, 0. And what we're now going to do is we're ultimately going to just use this same parent graph table, but now move all of our points certain directions. So we're going to use this parent graph table not as ordered pairs anymore, but as movements from our vertex. So for example, so when we graph parabolas that are shifted, we use the parent graph table as a guide. So here's our first one, graph our parabola. And we have y equals x plus 4 quantity squared. So it opens up because the a value up front is a positive. It is shifted to the left 4 units. Remember, this is really like x minus a -4. And we'll do our domain and range after we graph it. So remember, our vertex is normally at 0, 0, but we're now taking that vertex and moving it left 4. So there's our new vertex. If you want, you can either refer back to the parent graph table up here, or I'm going to just rewrite it here so it's on the same screen. And remember, the 0, 0 is our vertex. So, and now, instead of thinking of these as ordered pairs, we're thinking of them as movements from our vertex. So, we already have that plotted. That's right there. So, from our vertex, we're going left 1 and up 1. So, there's my vertex, left 1, up 1. From my vertex, again, you always have to go back to the vertex. I'm going left 2 and up 4. So, go back to your vertex, left 2, up 4. Go back to your vertex and go right 1 and up 1 from my vertex. Here's my vertex, right 1, up 1. And then again, go back to your vertex, and you're going right 2 and up 4. And there we have it. We just accurately graphed this parabola without using a calculator, without plugging values in to the equation to make a table, without using a calculator. We just did it using our knowledge of the parent graph table and our knowledge of moving parabolas around. All right, and here's our domain. Would be, again, all real numbers. Parabolas always have domains of all real numbers. And the range, it touches the y value of 0. So it'll be a bracket 0, and then go up to infinity. All right, another example. Here's our equation y equals -x minus 5 quantity squared plus 3. So this is going to open down, and it's going to be shifted to the right 5 and up 3. So first thing you always do is plot your vertex. So my vertex is normally 0, 0. I'm going right 5 and up 3. There's my new vertex. And again, I'm using this table as movements from the vertex now. So normally we go left 1 and up 1 from the vertex. So I'm still going to go left 1, but now that it's opening downward, it's a little different. Instead of going left and up, we're going to go left and down 1. And that's because it's opening down. We go back to the vertex, and again we have the -2, 4 next. So that means from the vertex I'm going left 2, and again, since it's opening down, I'm going down 4. And then again, you should always have that mirror on the other side, We're going to go right 1 from the vertex and down 1. Go back to the vertex, right 2, and down 4. There we have it. We'll just accurately graph that parabola. All right, our domain would be, again, all real numbers, negative infinity to infinity. And our range, it goes down forever, negative infinity, up to 3 and touches 3. All right, try these 4 on your own. We're going to go over a couple of them shortly. All right, for number 1, this would open up, and it's going to the left 3, down 8, so left 3, down 8. Again, we're using that parent graph table from the other side. Left 1 from the vertex and up 1, go back to the vertex, left 2 and up 4, because again, negative 2 squared is 4. Right 1, up 1, 1 squared is 1, go back to the vertex, right 2, up 4, because 2 squared is 4. Okay, I hope you guys should be able to do domain range. I'm not going to go over that with you right now. This one's going to open down and shift it up 5. So we're starting up here at 5. Since it's opening down, I'm going left and 1 and down 1 now. Go back to the vertex, left 2 and down 4. Right 1 and down 1. And then again, right 2 and down 4. And again, we're going down because it's opening down because of that negative in front. Again, I'll let you guys finish the domain and range. For number 3, this is being moved to the right 3 only. Oops. Opening up and right 3. So right 3. And then again, we use that same movement. Negative 1 squared is 1, so from the vertex, left 1, up 1. Negative 2 squared is 4, so from the vertex, left 2 and up 4. 1 squared is 1, so from your vertex, right 1 and up 1. And then 2 squared is 4, so from your vertex, right 2 and up 4. There we have our accurate parabola. And last one, number 4 is opening down because of the negative in front, right there. It's moving right 6 and up 4. So to the right 6, up 4. We use our same pattern. Negative 1 squared is 1, but since it's going down, opening down, we're going to go left 1 and down 1. Negative 2 squared is 4, so left 2 and down 4. Right on the x-axis. And then again, we'll always have that mirror image on the other side. 1 squared is 1, but we're going down. So right 1, down 1, and then right 2 and down 4. All right, there you have it. We do have some tricks to these coming up in a little bit, or some twists and turns to it, but for right now, that's what we got.